Hello students, good evening. Welcome to another lesson from Vedantu, Karnataka. Can you all quickly know if I'm live, if I'm audible and visible? Yes. Oh, so many people are waiting. Sorry for the 2-minute delay. There was a small technical error. Hi everybody. Hi Himnish. Hi Shivakumar. Hi Suman. Hi Puneet. How's all of your preparations? Are you all fully ready for your exams? All set? Can you let me know how your preparations are going? Hi Sunma. Hi Dikshit. Hi Sweta. Yes, so as the thumbnail suggests, today we're going to do 100 plus MCQs. Okay. So some of the MCQs are previously asked MCQs. Some are, from the NCRT. So hopefully we will have MCQs from this lesson. I mean, whatever PDF I have today. How to get 70 on 70? Have you prepared very well to get 70 on 70? Yes, I know Sachin, the exam is on 26th. Oh, Sapphire Soul is almost done with the preparation. Very good, very good. So, shall we start? If you're all ready, shall we start? Yes, I want all of you to answer the questions quickly. Okay? Yes, ready? Can I have some energy in the chat? Can you put some fire emojis in the chat if you're ready? Yes. MCQ is the only problem, okay? So I have put as many questions I could make, I have put all those questions, okay? Hopefully this will help you all. Alright, since Chetan said start, we'll start. Okay. Quickly, students, we will do question by question. I want you all to answer. Alright? And no other discussions in the chat, only discussions about class. Alright? Because there are students who are seriously studying. So let's respect them. Alright, first question. Physical quantity measured in terms of coulomb is A. Electric charge, B. Electric current, C. Electric flux, D. Electric field. What is the answer? A. Okay, I've got so many A's. Okay. Okay, what is the answer? Yes, so many people are saying A, so many people are saying B. Yes, students, quickly. Just a second, students. 1 second. Just a second. One second. Okay, sorry. There was a small thing that I had to. Sorry. Hi, Preetham. Hi. Yes, so all of you have already answered it. It's right. It's option A, electric charge. Right? Yeah, it's electric charge. Obviously, what is coulomb? Coulomb is the unit of electric charge. So, yeah, no need of a lot of explanation for that. Second question, students. Quickly, the substance which allow electricity to pass through them easily are called. Is it conductors? Is it insulator, semiconductor, or none of these? Which one? Quickly, let me know. Quickly. Yes, can I know what the answer is? Yes. Okay. Srinivas has said A. Vijaypriya says conductors. Sweta says A. TSB says A. Sneha Shetty A. Conductors A. Yes, very good. You all have 2 marks. Okay, the question number is wrong. Ignore that. You all have 2 marks now. It's conductors. Very good. Superb students. Next question. Newton Coulomb is the SI unit of. Yes, can I know the answers? Newton Coulomb is the SI unit of. Yes, is the SI unit of? Is it electric charge, electric flux, electric field, or electric potential? Okay, so many A, so many B. Okay, yes, Newton per coulomb is the SI unit of. Why am I not getting any B, C, D's? Okay, I have someone. Srinivas said C, Sweta says C. Okay, good, good, good. Yes, Preetham. Yes, Vijaypriya. It is electric field. Yeah. What is electric field? It has to be Newton by Coulomb, right? Force by charge. Yes, Vijaypriya, you're always correct. So all those who got all 3 correct, you have 3 marks now. Okay, very good. Superb, superb. Question 4. The minimum amount of charge that can be transferred from one body to another is 1.6 into 10 raised to minus 19. 1 coulomb, 9 into 10 raised to 9, 8.854 into 10 raised to minus 12. What is the answer? Quickly, let me know in the chats. What is the answer? Yes. Question 4. C. Okay. Everybody says, okay, A. A. Alright. Shivakumar says A. Delhi Kamalu says A. Yes, it's obviously A. What is the answer? 1.6 into 10 raised to minus 19. Why? Because it is the charge of a single electron. Very easy questions. I have very hard questions also. For some of you are thinking, ma'am, these are all very easy. Wait. Okay, we have 100 plus questions. Next question. The law governing the force between electric charge is known as Ohm's law, Ampere's law, Faraday's law, Coulomb's law. What is the answer? What is the answer? What is the answer? A. A is the answer to this one. No, Delhi Kamalu, I have not forgotten you, don't worry. Yes, quickly. What is the answer? Ohm's law. Yes, yes. Good, Avi. Very good, Avi. Very good, Srinivas. Very good, Chetan. Shripat, Ritesh. Um, Preetham. Sapphire Soul, Himish Gowda. Yes, it is D. What is Coulomb's law? The force between, it tells you that the force between the two charges is proportional to the product of the charges and distance inversely proportional to the distance. Obviously, Coulomb's law. Next question. How many electrons must be removed from a body to get a charge on the body? How many electrons must be removed? Okay, let's just highlight the answers. Yes, what are the answers? Question 6. I don't have any answers. Okay. Hi, Gagan. C. I have C. I have B. Who said B? Who said B? Nobody said B. Okay, I saw someone saying B. Shweta Chandran says B. Okay. Okay. Yes, Vijay Priya. So the answer is 6.25 into 10 raised to 18. How is it 6.25? What is the answer? 1 coulomb, right? 1 coulomb is 1 divided by 1.6 into 10 raised to minus 19. So how much you will get? 6.25 into 10 raised to 18. Alright. So this is the answer. Okay. Next question. The SI unit of electric field. Very easy question. Very easy question. SI unit of electric field. Yes, within seconds I should be getting the answer. What is the answer? Yes, Newton per coulomb. Why? Because electric field is what? Electric field is force per unit charge. So it is obviously Newton per coulomb, which is option C. Okay? Super. Super. You're all calculating your marks, no? I mean, you won't get all these MCQs for your exam, but still. Next question. The electric dipole placed in a uniform electric field is an unstable equilibrium if the angle between the electric field and the dipole moment is how much? How much is the answer? Is my chat stuck or are you all answering? Question 7. Okay. Yeah, now I got the answers. So I have Amulya, Delhi Kamalu, Shweta, Ritesh, Preetam, Inky Pinky Ponky. Inky Pinky Ponky won't help you. Okay, you need to know the answers. No Inky Pinky Ponky. Yes. Very good. It is 180 degree. How is it 180 degree? Yeah, I'll try to do numericals tomorrow. Okay, don't worry. Yeah. So, yeah, so many people have said 180 degree because, yeah, obviously the dipole is aligned opposite to the electric field. So, what should the angle be? It should be 180 degree. Okay, next question. Question number 8. The total electric flux through a closed surface in air is equal to 1 by epsilon naught times the total charge enclosed by that surface. This is the statement of Coulomb's law in electrostatics, magnetism, Gauss law in electrostatics, Ampere's circuital law. The circuital belongs to Ampere, okay? Sorry for that. This circuital comes under Ampere's circuital law. So quickly tell me the answer, students. Yes. What is the answer? What is the answer? Where is it? Okay, so I can mark. I didn't mark the answers till now. Ma'am, passing package important questions. Passing package important questions, I've already done a video. You can just go refer that, students. Yeah, where are the answers? Okay, I've got so many C's. Okay, so many C's. What is the answer? Yes, all those who said C, you can put a mark in your pocket. The answer is Gauss law in electrostatics. Very good. All those who said C, very good. Why Gauss law? What does Gauss law say? The total electric flux through any closed surface is equal to the charge, the total charge that encloses it. The same statement, obviously. Next question. The SI unit, the SI unit of surface charge density is. The SI unit of surface charge density is. You need to know concepts also. Even if you do previous year papers, not all questions come just from that. So you need to know your NCRT very well to get 70 on 70. That's very important. Okay. B. Alright. I get some B's. Alright. Sapphire Soul, Delhi Kamalu, Vijay Priya, Shweta, Shivakumar, Sneha, Sinchan, Alex, Vikas, Murugesh. Okay. So many people say B. So if everybody say B, then how can I say that it's wrong? It's obviously B. So surface charge density is what? It is charged by area. So charge. Oh, what happened? Sorry. It is charged by area. Now what is charged by area? Coulomb by meter raised to minus 2. Area is meter square. That's why. Okay. Next question. The electric potential due to an electric dipole falls off at large distances along the axis as. This is also a very easy question. What is the answer? Hi Ganavi, good evening. Quickly, let me just check how my video is going. Yeah, are you able to read the question? Is it blur? Quality. The kind of doubts you all have. Quickly tell me the answer. A, okay. So many people tell me A. A. Okay. Nobody's telling me D. No D's. All are saying it's A. Okay. So this question you'll find out. Okay. It's a very easy question. You should all be telling me the answer quickly. It's a very easy question. Very direct question. So let's move on to the next question. What happened? What is the next question? The electric potential due to a negative point charge at a distance r is. Ma'am, F. F is the answer. Okay, Alina says it's D. Okay. Alright. The electric potential due to a negative point charge at a distance r is. What is the answer? Is it positive and varies by 1 by r square or varies by 1 by r? Negative varies by 1 by r square. Negative varies by 1 by r. What is the answer? What is the answer? D. Okay. Alex says it's D. Anybody else? Anybody else? Alex is the only one. Okay. So many are giving me C. Okay. Murugesh says it's C. All right. Okay. Okay. What is the answer? Ma'am, full blur. Is it fully blur? It was blur on mine also. What you can do is increase the quality of your video. Okay. So if it's auto, increase the quality of the video. I think that is why it shows blur. Alright. Because now it's not blur on my device. Is that fine? So the answer, okay, yeah, I was got to discuss the answer. So here, the answer is. So someone said it is D. Yes, the answer is negative and it varies by 1 by R. How? Because V is equal to K Q by R. potential. So only one R in the denominator. So V is equal to KQ by R. And it is a negative point charge. So obviously Q is going to be negative. So electric potential will also be negative and it varies by 1 by R. Alright. Okay, let's move a little more faster. Next question. The electric field inside a charged conductor is 0. This is known as the electric field inside a charged conductor is 0. This is known as, what is this known as? What is the answer? What is this known as? C? Okay. Very good. Who is that? Ritesh. Very good. Very good, Ritesh. Others. Give me the answer. S. Olive. Yes. Shweta, Shinchana. Very good, students. Delika Mallu. Yes. Yes, Shivakumar, Pavin, Sapphire. So many people giving me C. So I also agree with all of you. The answer is C. Okay. What is the answer? It is C, electrostatic shielding. Now, what is electrostatic shielding? Yeah. So, the electric field inside the cavity of a charged conductor is always 0, isn't it? Why? Because of the redistribution of charges. Now, on the surface, every field cancels out any internal field. So, that phenomena is actually called electrostatic shielding. You might have learned this in your PU. Okay. So, electrostatic shielding is when inside the conductor there is no charge. Okay, let's move on to the next question. The SI unit of electric charge is? What is the SI unit of electric charge? Easy peasy question. Vedant, what is your doubt, ma'am? Just reading 15 lessons chemistry, does it give 110 in NEET? It depends on how you read it. Okay. Yes, Bhuvana, is Sala Cup Namde. Yes. You can ask your chemistry teacher. Alright, you have chemistry lessons tomorrow, so you ask her about it. Okay? Yeah. So what is the answer to this one? Quickly tell me the answer. B, C, Coulomb. Okay? Okay? Yeah. So many questions with Coulomb as the answer, no? SI unit of electric charge we already discussed. It's Coulomb. Okay, next question. An example of a polar molecule is? This concept I already explained in my last video, passing package. There I've discussed polar molecule. An example of a polar molecule is? Quickly. See, polar molecule should be having a bent kind of a shape. Shambhavi. What did I ignore? I don't see, dear. The chat is going very fast. That's why some messages I don't see. I'm really sorry. Yes, see, very good. Who answered first? I can't find out who answered first, but Bharati has answered. Alex, Sanchana, legend. Yes, Kirtana. So many people have answered. Okay. So the answer is water molecule. Example of a polar molecule is water molecule. Super. Next question. Water molecule is a polar molecule because, okay, it's a sub question to that. Why is water molecule a polar molecule? Why is it a polar molecule? C. Okay, I get so many C's. So in polar molecules, how should the centers be? Should they coincide or should they not coincide? Ma'am, it can be C and D. Okay. B, so many B's. Ma'am, hopefully, okay, for MCQs, I'm giving you some practice, but not necessarily these questions itself will come. You might get similar questions. MCQs can come from anywhere in your NCRT. Okay, so we are practicing some questions. If questions from this come, you will be lucky, but not necessarily questions from only this might come. Okay, yeah. Okay, so many B's. B, 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 B. Okay. Okay, B. If everybody says B, I also agree it is B. So, in a polar molecule, the centers of positive and negative should not coincide. And they have a permanent dipole moment. It says option C is wrong because it says it does not have, but they should have a permanent dipole moment. Okay? Yeah. Very good, very good. Very good. Quickly, next question. The value of electric field and electric potential at any point on the equatorial plane such that, what is the answer? Ma'am, say to like, okay. People are missing me telling like. Did you all like the video? This is JE 2024 question. Okay. I getting B, C. Yes, all of you please like my video. Bhuvana has reminded me to say that. Did you all like and subscribe? Please go like and subscribe. I had forgotten about that, but Bhuvana has reminded me. B, B, C. I have more participants and less likes. Where are my likes? Okay. So you'll find out this question and put the answer in the comments. Okay. Under the video, I want you to all answer this in the comments. Okay. Next question. If the potential across a capacitor is double, then the energy stored in it is. If the potential across a capacitor is doubled, then the energy stored in it is. Hi Shanmuka. Hi Spurti. Yes, quickly tell me the answer. C. Okay. Someone says C. Someone saying C. Others? B. Okay. I have C. I have B. What is the formula? Huh? B, B, B. Very good. Amulya, Bharati. Very good. Very good. Yes. What is the formula? E is equal to half CV square. So if the potential across a capacitor is double, then what happens? If C is the capacitance, V is the potential difference. If the potential difference V is double, then the energy stored will become 4 times because it's V square. Simple. It's 4 times because the energy depends on the square of the voltage. So the answer is quadruple because it has to become 4 times. Very easy. Quickly, next question. We have to do 100 plus questions, so let's move a little more fast. Okay, so if a charge moves once around an equipotential surface, then the work done by it is. Today RCB match. Every time I have a class, RCB will have a match. Why? We are directly proportional. Every time there's physics class, there will be RCB match. And all my students will go for RCB match. Yes, Abhay, we will think of COMEDK. Right now, your exam 2 is coming. So let's focus on that. One step at a time. Okay? Yeah. Amulya says B. Okay, very good. Shreyas, Delhi ke Mallu, Murugesh, Pavan Kumar, Ganavi, Himnish. Am I pronouncing your name right or wrong? Okay, so if all of you say B, I also agree it is B. So if a charge moves along an equipotential surface, then there is no change in potential energy. Why? Because the potential at every point on the surface is the same. Since the potential at every point on the surface is the same, the work done by the electric field is what? 0. So the answer is 0. Yes, ma'am, it is B. So many people are saying B, ma'am, B, ma'am, B, ma'am. Yes, it is B, ma'am. It is 0. Okay? Yeah, right? Okay, thank you, Himnish. I'm pronouncing your name right. Okay, next question. Again, there are some bracket, spacing problems. Ignore that because the question is correct. The maximum electric field that a dielectric medium can withstand without breakdown is called. Hi, Manoj. Yes, it's B, ma'am. RCB will win or lose. What all do you want me to predict? You want me to predict if these questions will come in your exam? You want me to predict if you will get 70 on 70 if you do this? You want me to also now predict if RCB will win today's match? I think I should quit teaching and go for some other job now where I predict future. D. Delhi Kamalu, Ritesh, Saina, Haswin. Oh, hi, crazy boy. These are all my regular students. That's why I know them. Ritesh, Shreyas, Murugesh. Bhuvana, my video is stuck. Hey, can someone else tell me if my video is stuck? Yes, what is the answer? Yeah, so many people said D. So the answer is D. Dielectric constant. Why is it dielectric constant? Because the maximum electric field in the dielectric medium, the maximum electric field that a dielectric medium can withstand without breakdown is called its dielectric strength. It is its strength. See, it's a direct question. Without knowing what dielectric strength, you can answer this. Because it is a maximum strength. Okay? Yes, next question. Next question. Let me increase my brightness. Now it might be better for you, no? Video correct, Anna? Okay, thank you. Okay, question number 20. Which of the following is the SI unit of capacitance? Quickly. Someone say the IPL score. Nobody will say the IPL score in my chat. Okay, you only tell me answers. A, B, C, D. Okay, Abhay, I'll try my best. Okay, I'll try. B. So many B's. Okay, so everybody is saying it's B. So let me also say that it is B. What is the SI unit of capacitance? Farad. Direct question. Next, the capacitance of a parallel plate capacitor is independent of area, distance, electric medium, potential difference. What is the answer? Yes, ma'am, ABD. There's no option ABD. There's either A, or either B, or C, or D. Okay? B. So many B's. Hey, does it depend? Does it not depend on the distance between the plates? What is the formula? In the formula itself, you have distance. So it will depend on the distance. Can't see question. Who can't see question? Now can you see question? For those of you who can't see question, you can listen to me. I always read the question once. Okay. Yes, very good. The answer is potential difference between the plates. Okay, the capacitance of a parallel plate capacitor does not depend on potential. It depends on area, it depends on distance, it depends on dielectric. What is the formula? The formula has A, epsilon, it has K, it has D. So obviously it depends on all three. If you know the formula, you can easily write it. If you don't know the formula, you can watch my previous video. Promoting my old video in between. Okay, the capacitance of a capacitor is 6 into 10 raised to minus 6 farad. It is connected to 200 volt cell. The energy released on discharging it fully will be. The energy released on discharging it fully will be. Quickly, you should take only 2 seconds to solve this. Solve. Tell me the answer. Yes, anybody solved it? C. Yeah, Yashish is saying the formula is C is epsilon naught A by D. Very good. If you have a dielectric in between it, there is a K also. That's why it's dependent on K also. Okay. What is your doubt, Prema? Prema has a doubt. Hi, Pallavi. Ma'am, please, important question. 2 mark, 5 mark, 3 mark. Yes, yes. I saw your message, Prema. I said hi also. Okay, quickly, tell me. Yes, what is the formula? E is equal to half CV square. So this is half into 6 into 10 raised to minus 6 into 200 square. So if you quickly do the math, this is 3, 3 2s are 6. Sorry, no. Okay. This is 2 square. So it will be 4. This will be 3 into 10 raised to minus 6 into 41212. So 4 3s are 12. But it's not going to be 12 because there is a 10 raised to minus 6. So it's definitely not going to be 12. So the other answer that has 12 as option is 0.12. So that would be your answer. Okay? Is that clear? See, you can just write this very easy calculation. 10 raised to minus 6 into 10 raised to 1, 2, 3, 4. And then 12. That's all. Are you getting this? Yes. 68. Come on. Are all your friends attending the class today? All those who are writing exam 2, go tell them. Important MCQs are being discussed. Come join. Catherine ma'am is waiting. Go call them. And did you all like, share and subscribe? Yeah? Okay, next question. The angle between the equipotential surface and electric field is the angle between equipotential surface and electric field. No, there will be more questions. What about dinner? You don't have to eat dinner at 8 o'clock is too early, no? I'll send you for dinner, don't worry. Hey Vijaypriya, that's very bad. You should go tell your friends. Let them also join the class. All of you should score good marks, no? If all your friends score good marks, it will be very good. You should be very happy. Yeah, quickly, quickly. What is the answer? A. Yes, very good. The answer is 90 degree. Why is it 90 degree? See, the angle between an equipotential and an electric field is always 90 degree because electric field lines are always perpendicular to equipotential surfaces. So, for properties of equipotential surface, I've taught this to you. The electric field lines and equipotential surfaces are always perpendicular to each other. Very good. Super. Next question. The correct relation connecting the electric field and electric potential is it E equals minus dV by dx or E equals dV by dx, V equals minus dE by dx, X is equal to minus dV by dx. What is the answer? What is the answer? Yeah. Haswin is eating dinner and watching. I'm happy you're not watching anything on Netflix, but you're watching my channel and eating dinner. Good. A. Okay. I get so many A's. A. Superb, superb. Okay. All those who said A. Okay, zoom the question. Very good. The answer is A. E is equal to minus dV by dx. Right. Electric field is a negative potential, is a negative gradient of electric potential. There is an important derivation in your book. Prove that electric field is a negative gradient of electric potential. If you learn the derivation, you will get the answer to this also. Okay. Somebody asked me to zoom. Okay, can you see now? Yes. Okay, next question. The magnitude of the drift velocity per unit electric field is called. What is the magnitude of drift velocity per unit electric field? What is it called? What is it called? Mobility, which is Vd by E. Super. The answer is mobility. See, some of them are giving me explanation as well in the chat. Super students, you're all very brilliant. Okay. Why? Mobility is, what is mobility? Mobility is a measure of how quickly charge carriers like electrons move in electric field. So obviously it is drift velocity per electric field. Okay, next question. The current density is a scalar vector. And what is its SI unit? Is it A m square, A by m cube, A by m square, or A by m? So quickly tell me the answer. Yes? Oi. Yes, Uday. Oi. What is that? Yes. C. Okay. I have a C. Very good. Yes. Good. 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 Good, Shreyas. Good, Vijay Priya. Good, Yashes. Good, Shiva Kumar. What is confusing here, dear? See, current density is it a scalar quantity or a vector quantity? It's obviously a vector quantity because it has both direction and magnitude. And what is the formula for current density? It is ampere per meter square. So the answer is going to be option C. Alright. What is it? Yeah. Okay, because it's a vector quantity and its SI unit is ampere per meter square. Okay, next question. The resistance R of a metallic conductor is inversely proportional to the length of the conductor, B, area of cross section of the conductor, both length and area of cross section of the conductor, D is temperature of the conductor. Quickly tell me the answer. Yes, I am from Mars. Yes, Himnish. Do I look like an alien? Ritesh says is B. Okay. Others? See, what is the formula? R is equal to rho L by A. So, what is the only thing on the denominator? Tell me. So, the only thing is what it is inversely proportional to. R is equal to rho L by A. So, the only thing on the denominator is A. So, it has to be inversely proportional to area of cross section. Super. Next. The electric field E, current density J, and conductivity of a conductor are related as sigma equals E by J, sigma is JE, sigma is 1 by JE, sigma is J by E. This is also a derivation that you have to study in your exam. What is the answer? What is the answer? What is the answer? Okay. Okay, so many B's, so many A's. Students, some more energy. Yasha says it's D. Okay. B. Okay. Yeah. Kirtana, very good. Geeta, good. Okay, I see new names. Netravadi, good. Good, good, good. What is this name? What is it? Chrysolite. Murugesh, good. Okay, Arun Kumar, very good. Okay, so all those who said B, it is B, J, sigma, J. J is equal to, wait. No, it is D. Sorry, it is D. Right? It has to be D. Because J is equal to sigma E. So sigma should be J by E. Okay. So for 20th question, it is D. Alright. J is the current density. Sigma is electrical conductivity. E is the electric field. Okay. Yes, ma'am. D. Okay. Okay. Next question. A wire of resistivity rho, resistance R and length L is cut into 4 equal parts. Resistivity of each piece will be 3/4 of the original value, half of the original value, same as the original value, 1/4 of the original value. What is the answer? The resistivity of a wire. See. Okay. I want to know the answer of this one. What are your answers? Ritesh says it's C. Uday says it's C. Haswin. How do I pronounce it? Murumala, okay. Amulya. Okay, Yashas has typed the whole answer. See, are you all really getting it, or when I say one alphabet, you're all just putting that? I trust you, I trust that you're all getting it, okay? Yes, obviously, what is the answer? Same as original value. See, resistance, R is rho L by A, but resistivity is something that depends on the material. It does not depend on length or area or anything like that. It depends on temperature and the nature of the material of the wire. So it shouldn't change when something like length changes. Resistance will change, resistivity will not change. Is that clear? I've explained this so many times. Okay? Yeah. Next question. As the temperature of a conductor increases, then its resistance. What happens to its resistance? As the temperature of the conductor increases, what happens to its resistance? Madam A, okay. Hello, Madam C, okay. See, here it is not resistivity. The question is resistance. Be careful. Is it C? Okay. So many people saying is A. MBR events. Hi, MBR events. Craft girl. Hi. Yes. Okay. So many people are telling me A. Okay. Yeah. If so many people tell me A, you're all smart kids. You can't be wrong. So it should be A. See, what happens when temperature increases? Inside the wire, particles gain more energy, they move faster. So then they will have more resistance. You can just consider, a crowded street. Okay. In a crowded street, and if there's a crowded street and you want to cross from A to B, from the end, beginning of the street to the end. In a crowded street, it is difficult for you to cross. Now imagine in the crowded street, people are running around. That is what happens when you heat up. So particles start running around. So what happens to resistance? It will be more. You cannot pass through. It will be very difficult. Okay? Yeah. Identify the wrong statement from the following. The drift speed acquired by free electrons per unit electric field is called mobility. The conductivity of semiconductors decrease with increase in temperature. The conductivity of conductors decrease with increase in temperature. Alloys are widely used in the construction of standard resistors. Okay. Okay. What is the answer? Let me look. No answer. No answer. Am I lagging or are you not answering? What is happening? I don't see any answers. The conductivity of semiconductor decreases with increase in temperatures, what Yashas says. Okay. Okay, Yashas. What about the others? Craft girl says it's B. Geeta says it's B. Okay. Ma'am, drink water. It's X. There's no option X. Okay. Okay. Autocorrect changed your answer. Mm-hmm. Okay. Yeah, it is B. See, the conductivity of a semiconductor will decrease with increase in temperature. It's inversely proportional. Alright. But what about the conductivity of a conductor? It will increase. Sorry, it will decrease. Why? When temperature increases, what happens to resistance? Resistance increases. So what should happen to conductivity? It should decrease. Okay, super. Next question, question number 32. Is this clear? See, when temperature increases, what happens? For the previous question, more and more electrons from the valence band will move to the conduction band. Okay? So, this is the wrong state. Alright? Because this is a semiconductor. Yes, I'll give you the PDF. Don't worry. Question number 32. Statement 1. The resistivity of metals increase with increase in temperature. Statement 2. Increasing the temperature of metals causes more frequent collision of electrons. Okay? Which of these are correct? Which option? So one option is both 1 and 2 are true, and 2 is the correct explanation of 1. Both 1 and 2 are true, but 2 is not the correct explanation of 1. 1 is true, but 2 is false. Both 1 and 2 are false. Oh my god, these options itself are all similar, no? Okay, I want you all to take time, read the question, tell me the answer. Yeah, quickly. Okay, so many people are telling me A. Okay, you guys are super smart. You guys don't even have a doubt. Okay, if all of you say it's A, it is A. Super. B. I have A, I have B. See, the resistivity of metals will increase, right? With increase in temperature. Why? Because at higher temperature, what happens? The atoms in the metal vibrate more, which leads to more frequent collisions between them, and hence the resistance will increase, or the resistivity will also increase. So resistivity depends on two things, temperature and the nature of the material. So obviously it will increase with temperature. Statement 1 is correct. And why is statement 2 also correct? That's what I already said. Why? When resistivity increases, what happens? Particles have more energy, they collide more often. Simple. Okay, next question. Mobility nu of a charge is given by. What formula is mobility given by? So there is a small correction here. Mu is E tau. This is mu is equal to tau by m, and then mu is equal to m by E tau. I don't know how all these got erased. I'm really sorry. Mu is equal to tau by m. Here it might be m by E tau, and then mu is equal to E tau by m. So what is the answer? You might have wondered what is happening here. Amulya says it's D. Okay. Yes, the formula is mu is equal to E tau by m, which is option D. Okay. Yes, Ritesh, it's option D. Yes, Kirtana, it's option D. A direct question. Right? You will not get complicated MCQs for your PU. Okay, this is not like KCET or JE or anything. For PU, you will not get a lot of complicated questions. Next question. Question number 34. Let me just use my mouse. In a uniform electric field region, electric field lines are equally spaced, parallel to each other, diverging or converging, both A and B. Quickly tell me the answers in the chat. Quickly. Yes. What is the answer? Yes, Murumala. I hope I'm pronouncing your name right. It is D. Shripath, D. San. Yes, it's Pakka D. Yes, good. Yes, Sushant, it is D. Uday. Okay. So many people have given me the answer D. Yes. So what happens in a uniform electric field? In a uniform electric field, the electric field lines are equally spaced and they're all parallel to each other. So that means electric field has the same magnitude and same direction everywhere. So it has to be A and B, both equally spaced and parallel to each other. Okay, next question. A parallel plate capacitor with oil as with a dielectric constant 2 between the plates has capacitance C. If oil is completely removed, the capacitance becomes. Okay. Then what does the capacitance become? Quickly, students, please go like the video. Let's make it 100 likes before the class ends. Okay? Quickly. Let's make it 100 likes. Have you all subscribed? Yeah? So please subscribe and like so we can keep giving you good content. Okay? Yes, what is the answer? D. Okay? I get so many D's. See, what is the formula before telling me the answer? What is the formula? C is equal to epsilon naught A by D. Now, if I have a dielectric, what happens? C bar will be equal to K times C. So, if the dielectric constant is 2, won't it be 2 times C? And how will it be? D. Oh yeah. So, C would be C bar by 2, which is D. Alright, because the question is, if the oil is completely removed, then what the capacitance is. Superb. You're all super smart. Very good. Quickly, let's move on to the next question. Yes, question number 36. Electric potential inside a charged spherical shell increases linearly with distance as we move from center to surface of the shell, decreases linearly with distance as we move from center to surface of the shell, increases exponentially as we move from center to surface of the shell, remains constant with distance as we move from center to surface of the shell. Yes, what is the answer? D. Okay, D. I get so many D's. Joshua, super is the answer. Or are you imitating me? What is the answer? Okay, Arun Kumar, Uday, Rachit, Haswin, Ganavi, all of them says it's D. See, the electric potential inside a charged shell will always remain constant. It will remain constant at all points inside the shell. And why is it? Because this is because of Gauss law. The electric field inside any spherical shell is 0. So, since the electric field is 0, the electric potential would be what? It would be uniform. So, that means the answer is option D, which means it remains constant because it has to be uniform. Okay. SI unit of magnetic field. Very easy. Very easy. What is the answer? Tesla. Yeah. SI unit of magnetic field is Tesla. Next, current I flows through a current I flows along the pipe of an infinitely long straight thin wall pipe. Then the magnetic field at all points inside the pipe is same but 0. At any point inside the pipe is 0. Is 0 only on the axis of the pipe? Is different at different points inside the pipe? Sapphire answer? What does Sapphire say? Okay, quickly. That will also be your homework. Let's make it. Next question. 39. Are you all answering? Students, you don't have to come and report on what people did in the match. Let's look at physics. A wire has non-uniform cross-sectional area as shown in the figure. A steady current I flows through it. Which of the following statement is correct? Which of the following statement is correct? The drift speed of electron is constant. The drift speed of electron increases while moving from A to B. The drift speed of electron decreases while moving from A to B. The drift speed of electron varies randomly. What is the answer? What is the answer? Okay, so many B's. Okay, so many C's. All right. What is the formula first thing? I is equal to NAEVD, isn't it? So the drift speed is related to current and cross-sectional area. So for if there's the steady current I, what happens? If there's a steady current I, what happens? C. Think properly. If there's a steady current I, what happens? See, when the cross-sectional area you can see from A to B, it's becoming big. The area is like this, it's increasing, right? So the drift speed also should change accordingly. I is the same. So in areas where the cross-sectional area is smaller, which is, where it is A, what should happen? Yes. Yes, very good. So in areas where the cross-sectional area is smaller, the drift speed should increase. And when area decreases, what happens? Increase, decrease. See, the formula is I is equal to NAE into VD, isn't it? So if the wire narrows, that is the cross-sectional area decreases from A to B. So the drift speed of the electrons will increase to maintain the same current. So I has to be a constant, NAEVD. Alright, so it has to be, oh, what happened? What happened? Nothing happened, no? Okay, so it's going to be B. Because it's I is equal to NAEVD to maintain a constant I. Okay. Question 40. Question 40. A charged particle charge q is moving in a uniform magnetic field. The angle between the velocity of the charged particle and magnetic field B is theta. The trajectory of the charged particle varies with angle theta. Match the following table by choosing the appropriate trajectory traced by the charged particle for different possible values of angle. What is the answer? You just have to match the following. So what is it going to be? Obviously, when it's a straight line, it's going to be theta equals 0. So 1 is definitely going to be B. Okay? So it's either C or option C or option B. Definitely not option B, definitely not option D. It's either option C or option B because straight line is always 0 degree. Next, let's look at theta is 45. What will theta 45 be? Would it be a helix or a circle? Obviously, it's going to be a helix and 90 degree will be for a circle. So the answer is going to be option B. Okay, I can't highlight it there. Oh, I put the answer here. Yay, that was okay, fine. Okay. Next question, also the answer is here, but still. The physical quantities related to magnetism are listed in column 1 and the dimensions are listed in column 2. Identify the correct match. So this is dimension. You should do it. Magnetic field. The answer is D. It's already written here. Shouldn't have been written, but still. Can you all do it? You have to find out the dimension of magnetic field, magnetic moment, magnetic permeability. You can actually find out of any two. If two are correct, then you can choose that option. Okay? Why are you so much obsessed with fire emoji? So Karthik has been watching all my classes. That's the proof that Karthik asked me this question. I didn't ask you to put fire today. Since you asked, can you all put the fire emojis in the chat? Since Karthik asked me why I am obsessed, can you all put some fire in the chat? Okay, next question. Next question. The column 1 is the list of materials and column 2 is the list of energy band gaps. Identify the correct match. So conductors should have a very small energy band gap, right? So conductors should have the smallest band gap, which is B. Easy. Energy band gap should be 0 electron volts. So where is it? Option 1 should be B. Okay, so it's either B or D. Okay, because 1 is B. So the answer is either option B or option D. Next, insulators should have a very high band gap. So it should be definitely greater than 3 electron volts. So it is option D. Alright, so it is depending on the band gap, the conductivity increases. 0 band gap, good conductor. Small band gap, semiconductor. Very high band gap, it's an insulator. Alright? Alright? Stadium is full of hearts. Okay? Yes. Okay, quickly. Next question. To convert a galvanometer into an ammeter, one should connect. I'm sure everybody will know the answer to this one. How to convert a galvanometer into an ammeter? Quickly, quickly. Yes, Amit, tomorrow there is a class for very important questions. Okay, tomorrow evening, everybody during the day, full revise, full be ready. In the evening, we will do one revision with important questions. Okay. Me says it's B. C, yes, Pavan Kumar, very good. Sanvi, yes, Sanvi, it's good. Haswin, very good. Very good, very good. Yes, Ritesh, low resistance in parallel. Super. So the answer is low resistance in parallel. This is also a question you might all have studied in your PU. Obviously, this is your PU exam. So all these you have studied in your PU. Yes, Ganavi, very good, very good. Next question. A moving coil galvanometer can be connected into a voltmeter by connecting. By connecting what? By connecting. Amit, class time. Class time, I have not decided yet. So it will be scheduled. You can just check go to Vedantu, Karnataka and the live will be scheduled. Okay. So the time will be there. Alright. Yeah, 45. What is the answer? D. Amok, Ritesh, Arun. Sarcastic. I can't pronounce your name. I'm really sorry. High resistance in series. Yes, the answer is high resistance in series. Superb. You will all get full marks for MCQ. Okay. The net magnetic flux through any closed surface is zero. Is in accordance with Gauss law in magnetism, Gauss law in electrostatics, Ampere's circuital law, Biot-Savart's law. Is it B? Is it D? Oh, I missed a question. Okay, I'll come to that question. Next. Gauss law, yes, superb. Superb, you're all making me very proud, Very good. It is A. Next question. Below are two statements related to magnetic flux and magnetic field lines. First statement. The net magnetic flux through any closed surface is zero. Statement 2. The number of magnetic field lines leaving the surface is balanced by the number of lines entering it. Okay. Which of these two are related to magnetic flux and magnetic field lines? What is the answer? Oh my god, no doubt I'm getting so many A's. Yes. Both statements 1 and 2 are correct and 2 is the explanation for 1. So I don't have to explain this again. 2 is the explanation for 1. Why? Because every field line that enters will leave it. That is why magnetic flux through a closed surface is 0. Very good. I'm not calling out your name because I've got so many A's. Superb energy students. If you all are, superb. Listening and enjoying the class? Can you quickly put some fire emojis in the chat? Yeah, did you all like the video? Like, share, subscribe, go. All of you go hit the bell button. Okay, Ritesh has already given me the answer for the next one. Okay, good. Tansi, hi. Sarcastic. Yes, me. Me with the cooling glass. Very good. It is magnetization. The net magnetic moment per unit volume of a substance is called magnetization. Yes. Superb, superb. Yeah. I feel these questions are very easy for you, no? Because you're all been doing KCET, JEE, NEET and all. You're all like, ma'am, what is all this? Easy peasy stuff. It's okay, Ganavi. If you don't want to be out, you answer these questions, okay? Okay, you're Likita. Alright, Likita. The universal property among all substances is diamagnetism, paramagnetism, ferromagnetism, and non-magnetism. What is the answer? A. Okay, diamagnetism. Yes. Yes. Okay, so we've reached 49 questions. Very good, students. Okay, so all materials exhibit diamagnetism to some extent because it's a property arising from the change in orbital electron motion. Okay, so you don't have to know that much. You can just know like paramagnetism and ferromagnetism is present in specific metals or materials, but dia is present in almost all materials. Okay. Yeah. The magnetic susceptibility of a diamagnet is. Oh, you're a multitasker, Ganavi. Very good. Super. Good evening, Mr. MK. The magnetic susceptibility of a diamagnetic material is. What is the answer? Can I have some answers? Yes, it is small and negative. So all this I've mentioned in the passing package. You have to learn all this. You know how susceptibility varies for all three different dia, para, and ferro. Okay? Cooked up. What is your real name, cooked up? The ferromagnetic material among the following is. What is a ferromagnetic material? Ferromagnetic material. Yes. Super. It's nickel. Okay? Nickel is the ferromagnetic. See, ferromagnetic materials are nickel, then there is iron, there is cobalt. All of these materials can retain their magnetism and they're strongly attracted by magnets. Okay? So, nickel is there, iron is there, cobalt is there. So, if the option is any three of this, you can mark it. Okay? Yes. Nickel, yes, very good. When a bar magnet is suspended freely, it points in the direction of. Obviously, it points in the direction of Earth's magnetic field and it is always north-south. Yes, it's always north-south. Very good. The phenomena in which an EMF is induced in a coil whenever the magnetic flux linked with its change is known as. Sorry, what is it known as? Is it magnetic effect of an electric current, mechanical effect of an electric current, electromagnetic induction, or photoelectric effect? You want to score out of out? You can score out of out if you have studied properly. Don't worry. C. Yes, very good, very good. It is electromagnetic induction. Very good. See, what is electromagnetic induction? It's a process where a change in magnetic flux through a coil induces an EMF in the coil. So if you know what electromagnetic induction is, you can see it is the same as the heading. Okay? Okay? Yes, Ritesh. Very good. Next question. A bar magnet is kept along the axis of a circular coil. If the magnet is rotated about its axis, then a current will be induced in the coil No current will be induced in the coil, and EMF and current both will be induced in the coil. Only an EMF will be induced in the coil. So what happens? What is happening? Again, there is a small correction in the question number. This is going to be question number 54. Yeah? What is it going to be? No current, small current. Quickly, students. Yeah, where are my answers? Yes, Pavan, Amog, all of you say it's B. Mm-hmm. Mm-hmm. Likita also says it's B. No current. Okay? So, see, when a magnet is rotated about its own axis along the coil's axis, there is no change in magnetic flux through the coil. So, there is no induced current or no EMF. So, the answer is option B. Superb. Next question. The magnitude of the induced EMF in a circuit is equal to the time rate of change of magnetic flux through the circuit. This is the statement of Lenz's law, Faraday's law, Ampere's circuital law, Gauss law. So if you know all these laws, you can easily find out the answer. Kirtana was waiting for me to drink water. Yeah, I drank water. Hey, Abhijit is here. Hi, Abhijit. Okay. Ritesh says it's B. Mm-hmm. See, Lenz's law is related to what? It is related to the direction of the induced current and EMF. So it states that the induced EMF will oppose the change in magnetic flux. But here, the statement that we are referring to describes which law? Very good, very good. It describes Faraday's law. So what does Faraday's law state that? Faraday's law defines that the magnitude of the induced EMF in terms of the rate of change of magnetic flux is what Faraday's law states. So it's going to be option B. I'm not able to select option B. Once again, option B, yes. Faraday's law. It's not A. Why is A also selected? Control Z. Okay, it is Faraday's law. Okay, very good. Next. Dhruva, you pray to God. That's the only thing you can do if you have been prepared. See, you have one more day. Okay? Relax. I have put the past package. You go through all of that. Go through the MCQs. Okay? You will do well. You prepared only for 5 marks. MCQs are here. You prepare for MCQs now. Yeah, what was question? Lenz's law is the consequence of law of conservation of. Law of conservation of. Yes, very good, Likita. Energy. Super. So they're all direct questions. If the number of turns of a solenoid is double, the self-inductance of the coil will. Self-inductance of the coil will. Question number 56. Doubled DG. Who said option G? Becomes 4 times. Half. Okay. Oh, what happened? Yeah, what will it be? It is L is equal to mu 0 n square AL, right? So it would be becomes 4 times. Alright. So it is n square. So if it is double, it will become 2n square. So it will become 4n square. So it will become 4 times. Alright. Cooked up has scored 91. Very good, cooked up. Superb. Okay. Inductance is a scalar quantity. Okay. This is a small typing mistake. So statement 2, I'll put it here. Okay. Statement 1, inductance is a scalar quantity. Statement 2, dimensional formula of inductance is. So what is the answer? Which option is correct? Both are correct? How to get marks without studying? I don't know. If I had knew, I would also have done that, no? I didn't know. That's why I had to study to get marks. Who is that? Who asked that question? Yashoda. C. Okay, Avijit says it's C. Others. It's V. Pavan Kumar says it's V. Okay. Can you write down what V is also, Pavan Kumar? C. Yes. Obviously, both the statements 1 and 2, both are correct. Okay. Next, 58. The polarity of induced EMF in a coil is given by. Which one? I already told you about this law. What is this law? What is this law? Which law provides, the direction of the induced EMF in a coil? So this law actually states that the EMF will always oppose the change in magnetic flux produced by it. Which is that law? Yes. Lensa. Yes, it is Lenz law. Super. Very good. Hi, Monkey D. Luffy. I didn't see you today. Yes. Yes, Abhijit, Rajat, Subhita, Kupda. Yes, it's A. Next question. The following statements are related to self-inductance. The following statements are related to self-inductance. First one. The self-inductance of a coil depends on its geometry and on the permeability of the medium inside it. The self-inductance is a measure of electrical inertia and opposes the change in current in the coil. Which is the correct answer? Both statements are correct. Okay, Pavan Kumar is telling me both statements are correct. What about the others? Others. B. So many B's. Okay. C. See, the answer is C. Both statements are correct. Okay. The self-inductance of a coil depends on geometry and permeability of the medium. It also is a measure of electrical inertia. Very good, very good. Next question. The energy stored in a inductor of inductance L in establishing the current I in it is. What is the formula? Quickly, formula. What is the formula? We have to move fast. We have so many more questions to do. What all questions you have, Dhruva? You tell me the correct option now. Yes, super. The formula is half L I square into. Why am I not able to highlight it? I'm not able to highlight it. Something happened. Okay. Yeah. So, the energy stored in an inductor is given by the formula half L I square. L is the inductance, I is the current flowing through the inductor. So, this is the formula that represents energy stored due to magnetic field. Yes, super. Next question. Current in a coil changes from 1.6 amps to 0.2 amps in 2 seconds. Inducing an EMF of 2.8 volts. So, what do you have to find out here? You have to find out the inductance. You have to find out the inductance because the unit is H, right? The unit is H, so you have to find out the inductance. What is the formula for inductance? So the formula is epsilon is equal to minus L del I by del T. Okay. So what is L going to be equal to? Minus epsilon del T by del I. Now quickly do it. What is minus epsilon? It is minus 2.8 into 2 divided by minus 1 point. How much would it be? It would be 0.2 minus 1.6. 0.2 minus 1.6, so it will be minus 1.4. What are you all getting? What are you all getting? B. Hey, how are you getting B? Check, check, check. Minus 2.8 into 2 divided by minus 1.4. How minus 1.4? 1.6 minus 0.2 amps. Nobody is giving me the correct answer. Yes, who is that? Shreyas. Very good, Shreyas. Super. Shreyas is the only one who gave me the correct answer. Ganavi, Abhijit, getting 4. Yeah, now so many are getting 4. Yes, you will get 4. You should get 4. Okay? It is 4H. Yes, Likita, it's 4. Next question. SI unit of mutual inductance of pair of coil is given by. What is the SI unit? Obviously, mutual inductance SI unit. Any inductance SI unit is Henry. Next, mutual induction is the working principle of. Such an easy question. What is mutual inductance? It only works in a transformer. It has 2 coils, primary coil and secondary coil. From the primary coil, by mutual inductance, the secondary coil gets the voltage. The answer is transformer. Next, the frequency of alternating current in an AC generator is decided by area, number of turns, frequency of revolution, or strength of magnetic field. What is going to be the answer? Very good, very good. What is the answer? Yes, is it A, B, C, or D? C. C. So many are giving me C. Okay. Amulya says it's B. Ritesh is saying it's B. Is it really B? See, it's there in the question. The frequency of alternating current is generated by. The frequency of alternating current generated by an AC generator is determined by the frequency at which the coil rotates in the magnetic field. So the frequency actually shows you how often the direction changes, right? It's AC. So depending on the frequency, you get to know how often the direction changes. So the frequency of the alternating current is decided by the frequency of revolution of the coil. See, the number of turns will increase the amount of current, not the frequency. It will increase the amount. If you increase the number of turns or the strength of the magnetic field, the current will increase. Okay, but here the question is frequency. Okay? Yeah. Okay, next question. The relation between peak value of current Im and RMS value of current I is. What is the answer? What is the answer? Mm-hmm. What is the answer? Quickly tell me the answer. So, what is the relationship? Im is equal to square root of 2 into I. So, I is going to be Im by root 2. Which is that answer? Option E. Oh, sorry, this is the options are wrong. It's B, C, D, E. Okay, so it's actually option the last option. There's a mistake in the alphabets. C, which is option B. Isn't it option E? Can you all confirm? Yes, Princess Fuzzy, I will do numericals and important questions tomorrow. Okay. Yes. Okay. Okay. Let's move on to the next question. Oh, there is no square root in E. Oh, yeah. Yeah, so it's option B. Sorry. Yeah, no. You're all young minds, no? I'm little old, so I didn't see that. Yeah. Yes. It is I am by square root. See, here I wrote it properly, but in the options I didn't notice that. So it's option B. Thank you, Shreyas. Thank you. Thank you, Abhijit, for letting me know. Okay. Superb. Superb. You know, it makes me really happy when you point out all this. It shows that you're listening. Thank you, Amulya. Okay. Which of the following is independent of the frequency of applied AC? Resistance, inductive reactance, capacitive reactance, impedance. What is the answer? Old is gold. I'm not that old, okay? To be gold. 70 HM says it's A. Okay? S. Olive Pravachan says it's A. Okay, since all these people said it's A, Pritham says it's A. Okay, so let's go with A. Which of the following is independent of the frequency? Obviously, resistance does not depend on frequency. Resistance does not depend on it. Okay, next question. Very good. In case of a pure capacitor connected to an AC source, the phase difference between voltage and current through the circuit is. What is the phase difference? A, B, okay. What are the answers do I have? A, B, then what else? Hey. Naman, hey is the answer. Hi. Okay. Ma'am, are you still single? Yes, I'm teaching alone. There's nobody else with me. 90. What is pakka, ma'am? What is the option? Just simply don't say pakka. So I can see there are students who have attended my other classes as well because they're all bringing references from other classes. Happy? B. Yes, the answer is option B. Students, tomorrow I'll be doing one more class. That will be the last class before your exam 2. So I want full audience, okay? If you want important questions, numericals, everything I'll discuss in tomorrow's class. Ma'am, comedian. Oh my god, what all questions are coming? You want my Aadhaar card number also? The correct answer is option B, 90 degree. Pakka 90 degree. Okay. Okay, very good. See, in a pure capacitor connected to an AC source, the current leads the voltage by 90 degree. Okay. So, the voltage across the capacitor lags behind the current by 90 degree. This also I have taught you in past package. My previous video, if you go check that, you will see this. Okay. Next question. You remember me as Pakka ma'am. That's why I stopped saying that. Because I did too much Pakka. So I thought I'll change that. Okay, 68. The resonance phenomena is exhibited by a circuit only if the components present are. My name is not Pakka ma'am, okay? Somebody is asking. My name is Catherine. Alright. Yeah. What is the answer? Hi Chanu. Hey, all of you go invite your friends. Share this link to your friends. Quickly call all of them. Let's finish this class with a bang. We're almost at 69 questions. We'll finish quickly. So let's finish with a quick bang. Did you all like the video? Like, share, subscribe? Yes, the answer is L and C. Pakka B. Yes, it is Pakka B. It is L and C. Give harder questions. All this is easy. See, for PU, you won't get KCET kind of questions. You'll only get content-based questions. Okay? Next question. In a transformer, the windings of primary and secondary coil are wound one over the other to reduce energy loss due to what is it? Students, I only have 80 likes. Can you quickly make it 100 likes before the class ends? Yes? Let's quickly make it 100 likes. Rajat, my name is Catherine. Who was there on this thing, the cover. Yeah, done. Answer. Quickly. A. Yes, very good. Very good, Abhijit. Very good. Inchara. I remember Inchara. Hi, Inchara. Amulya. Hi. Yes, flux leakage. Superb. The answer is flux leakage. Okay. Next question. In a transformer, NP and NS are the number of turns present in its primary and secondary coils respectively. The transformer is said to be a step-up transformer if... What is your name? If... Answer. No, I'm not going to share any more details about me. Quickly tell me answers in the chat. If one person starts asking, everybody wants to know. Yeah. Catherine Pakka ma'am. What is the answer for this question, you tell me? Thumbnail. Yeah, that was the word I was thinking. Thumbnail. Yes, thank you. Thank you, me. Sometimes you don't get words. We're all humans, no? The answer is yes, very good. It's option A. NP less than NS because it's a step up transformer. So the output should be high. So whichever should be high, that should have more number of turns. So primary and secondary. So primary will have less number of turns. Secondary will have more number of turns because it's a step up. For step down, it will be the opposite. 15 minutes ಆಯ್ತು. So, what did I say I'll do in 15 minutes? Did I say something that I forgot? Is it 100 likes? It's not 100 likes yet. Quickly, students, make it 100 likes. Let's make this a super hit video. Where do you live? I live in my house. Yes. An ideal step-up transformer decreases current, voltage, power, frequency. What is the answer? What is the answer? What is the answer? Am I not seeing the answer or you are not telling me the answer? Where is the answer? A current. I like your, YouTube ID. Only for studies, no excuses. Okay? Yeah, cooked up liked my video. Very good. What about the others? Did you all like? All those who liked my video, go put a fire in the chat. All those who liked the video, please go put fire in the chat. It is A. See, a step-up transformer does what? What is the purpose of a transformer? It is for long distance long distance transfer of electricity. So when you transfer electricity over long distances, if you have very high current, it will lose a lot of energy as heat. So to prevent that, a step-up transformer decreases current and increases voltage for long distance transfer. Okay? I see very less fire. Okay, now I see some fire. Okay. Preetham's pouring water on all the fire emojis. Thank you, thank you, thank you. I know all of you like the video. Thank you very much, students. Next question. A circular conducting loop is placed in the plane of the paper to the right of a long straight conductor. Okay. Carrying current I in the upward direction. The direction of current induced in the loop is. I am everything's fan, not just RCB. Full fan. Yes, quickly, let me know the answers. Oh, that's petrol. Okay, Preetham. Oh my god. Yeah, quickly tell me the answer to this one. See, the long straight conductor, it creates a magnetic field that circulates around it, right? Use your right hand rule. If I is going upwards, what happens? Both C and D. Both C and D, okay. Others? Others? I have to answer this one. For your exam also, I'll answer this. Where is all the answers? Are you all sleeping? Hmm? All those who are sleeping, put some thumbs up in the chat. The score is 190. Now, what about my likes? How much is my likes? You go count that also and come. See, the answer is going to be option C. Okay? It's going to be option C, anti-clockwise if current is increasing. How will you get the magnetic field direction? See, the long... No, ma'am. Suvita and Chanu are sleeping. I'm sad because you're sleeping. It's only 78 likes. How sad. Let's make it 100 likes quickly. Okay, see the magnetic field direction. So if you look at a long straight conductor, okay, that creates a magnetic field, you can use the right hand rule. You will see that I is going upwards. I is going upwards and the magnetic field near the loop will point into the page. Alright. Now, what about increasing current? If the current in the straight conductor is increasing, then what happens? The magnetic field will also increase. But according to Lenz's law, what happens? According to Lenz's law, the induced current in a loop will always oppose the increase in magnetic field. Okay? Yes. So to oppose the increase in magnetic flux, which is directed into the page, the induced current will produce its own magnetic field that points out of the page. So that is why the induced current will flow in an anti-clockwise direction to create a magnetic field that opposes it. Okay. Some of you are like, ma'am, are you talking in French? No, I'm not talking in French. Okay. Next question. The expression for displacement current ID is. What is the expression for displacement current ID? Ma'am C. Ma'am C. Any ma'am D's? Ma'am D? Ma'am A? Oh, that's why you're sleeping, Janu. But still, you can score more. You can watch my MCQs. C. A. What is the answer? C. Okay. So this question also you will do as homework. This question, how many times I have taught? You have to go to my previous video, which is passing package. There I've clearly explained the displacement current ID is, and you have to comment the answer. Okay. It's there in the video. Option C, option D, so many options I have. Next. According to generalized Ampere's Maxwell law, B dot dl is equal to B dot dl is equal to. Thank you, Subida. Subida says it's 97 likes. So who is going to give me the other likes to make it 100? Quickly. A, is A the answer? Monkey D. Luffy says it's A. What about the others? Quickly, quickly. Quickly, quickly. What is the answer? A. Okay. Amulya also says it's A. Paka A. Last question. Okay, you can let me know in the comments. 100 likes. Okay, good, Apurva. A, C. Okay. A. Paka A. Option A. Superb students, it is option A. Very good. Okay. It is option A. Okay, let's move on to the next question. From now on, I'll be very fast. Electromagnetic waves are produced by what? Accelerated charges, stationary charges, charges in uniform motion, a conductor carrying steady current. Ma'am, second exam will be difficult. See, as I told you, I can't predict all the students. See, the kind of questions you're all asking me, you're asking me if the same MCQs will come, if it will be easy, if it will be difficult, how much you will score. How can I say all that? Let's just hope it will be good. Okay? Electromagnetic waves are produced by? Yes, Paka A. All of you gave me the correct answer. Very good. It is A. Next. Accelerated charges. Yes. The electromagnetic waves suitable for radar systems used in aircraft navigation are, which is it? Is it gamma, UV or microwave or IR? Quickly, quickly, quickly. What is the answer? Gamma, UV, microwave or IR? How is it? What is the answer? The answer is very good. Good, good. Microwaves. Yes. Hello. Who is this? Raju. You're going me. Me. Stay back. We'll finish now. Okay. Next question. The displacement current is due to. This also I've taught you in the previous chapter. In previous video. Tell me. What is the answer? What is the answer? Very good. It is change in electric field, because in displacement current electrons are not actually flowing like in a capacitor. It's because of the change in electric field on the two plates that it happens. Which of the following are not electromagnetic waves? Radio waves, beta waves, UV, X-ray. What is the answer? Which are not electromagnetic waves? C. UV. UV is electromagnetic wave. Radio wave is an electromagnetic wave. X-ray is also an electromagnetic. Remember that spectrum. Radio, micro, and then all of those. That spectrum, all of those are electromagnetic waves. So the only one that is not there is beta rays. So that is the answer. Beta comes from radioactivity. That is not an electromagnetic wave. Okay, thank you, Subhida. We have crossed 100 likes. Good, good, very good. Ma'am, PDF I'll upload after the class if you will get it to download. Okay. Which of the following EM waves have highest frequency? Which has highest frequency? EM.W is electromagnetic waves. Okay. So which electromagnetic wave has highest frequency? Which one is it? For that again you should know the table. Obviously it is, what is it? Is it radio waves or gamma rays? Highest frequency. Frequency means it will have so many waves. Which is the answer? Is it B or D? B or D? See, gamma rays have the highest frequency. They have the shortest wavelength and the highest frequency. Okay? Very good. Very good. Very good. Next question. Concave mirror produces virtual image when the object is placed at its center of curvature. Beyond its center of curvature, between its principal focus and center of curvature, within its principal focus. What is the answer? This also so many times we have discussed at different positions where all we have. You can go refer the previous videos and I want you to comment the answer to this one also. Okay? Yes, last questions. Yes, we're going to finish questions. We will do approximately 110 questions, but we're almost finishing. So quickly go grab all your friends, tell them, let's do 20 MCQs together. Okay? Quickly send this video link to all your friends and tell them we'll do 20 MCQs together. It will help you for your second exam. Don't waste time to come and do problems with us. Go invite, all of you go invite one friend and come. Let me see how many friends you all have. Snell's law of refraction invalid at an angle of incidence I is. Quickly tell me the answer. Did you all go invite one friend and come? Yes. Quickly tell me the answer. Ma'am, break. See, I'll give you a break in another 20 minutes, then you don't have to listen to me at all. It's just some 20 questions more. Simple. Very good. Option C. 0 degree. Snell's law of refraction is invalid at an angle of incidence which is 0 degree. Why? Sin I is sin R. Himnish invited Sapphire. Okay. Others, whom all did you all invite? Okay. Next question. The ratio of speed of light in vacuum to the speed of light in a medium gives. What does it give? What is the answer? What is the answer? Zero degree. C A Raju. Very good. Very good. What is the answer? The answer is absolute refractive index, because what is N? N is C by V. What is N? Refractive index. N is the absolute refractive index. What is relative refractive index? If you compare the refractive index of two medium, then that is relative refractive index. But A is absolute refractive index because N is equal to C by V. Okay? Okay? Yeah. Quickly, let's finish it off. Quickly. Modern telescopes called reflecting telescopes use a concave mirror rather than a lens for the objective. Okay. For the objective because No chromatic aberration in mirror. Giving mechanical support to a mirror is easier. So which one? Obviously, it helps get rid of chromatic aberration. It also gives mechanical support. So both 1 and true are true. Is there an option like that? Yes, it is option C. Both 1 and true are true. Okay, superb. Yeah, C. Good, good, good. Next, 84. A ray of light is incident on glass air interface at an angle greater than critical angle for the pair of media. Then the ray undergoes refraction, partial reflection and partial refraction, total internal reflection, grazes the surface at the interface of the two media. What is the answer? What is the answer? C. Okay. Yes, see, when a ray of light is incident on a glass air interface, if the angle is greater than critical angle, it will obviously undergo total internal reflection. All this I have taught you. Okay. Those who have been following classes have answered. Very good. Super. TIR, yes. An object of finite height. Okay, an object of finite height is placed in front of a concave mirror within its focus. It forms a real enlarged image, a real diminished image, a virtual enlarged image, a virtual diminished image. What is the answer? What is the answer? C. Okay. So many people are telling me it's C. C. Yeah, if you're all saying it's C, it's a virtual enlarged image. Yes. So when an object is placed within the focus of a concave mirror, the image formed is always virtual, upright, and enlarged. So it is C. Now for your exam, this can be made into convex. They can ask an object of finite height is placed in front of a convex mirror. It forms what kind of image? So you can get different questions. I am not going to tell you you'll get only these questions, but you might get similar questions. Okay? Next question. Okay, Chanu. Ganvi. Yes. Identify the statement which is true for a compound microscope from the following. Its objective is a convex lens of great aperture. Its eyepiece is a convex lens of smaller aperture. The image formed by its objective is real and inverted. Its eyepiece produces a final image which is virtual and diminished. Okay, what is the answer? 100 likes done. Okay, thank you, Himnish. Thank you all for liking the video. Subscribe as well. MN Cafe, hi. Hello. 100 likes done. Okay. My God, students. What is the answer? Yes, the image formed is real and inverted. Okay. Yeah. See, in a compound microscope, the objective lens always forms real inverted image. The real image is then magnified with which? With the eyepiece, which acts as a magnifying lens, and the eyepiece is what forms a virtual image that is viewed by the eye. Alright. Next question. When a point yes, 0.1k done. Let's make it 1k. Too much to ask for, no? Yeah. Next question. When a point source of light is placed at the principal focus of a thin convex lens, the shape of the emergent wavefront is spherical, spherical divergent, spherical convergent, plane wave, cylindrical wavefront. What is the answer? You are all not answering. What are you all doing here? Derivations tomorrow. So this is also homework quickly. All these questions I want you to comment the answers. You're not answering. Where are you all? Tomorrow derivations evening you will have a class with all important derivations and numericals. Don't miss the class. Okay. I'm going to do very important ones. Diffraction effect is exhibited by what all? Only sound waves, only light waves, only matter waves, or all types of waves? Huh? Yes, diffraction is the bending of waves around obstacles through openings, and this effect is there for sound waves, light waves, and matter waves. So the answer is going to be all types of waves. Okay? Yes. Another 15 questions. Quickly, students. Quickly, quickly, quickly. Morning class. Morning class I can't do because you have biology exam tomorrow. No, some of them have biology exam. I planned for a morning class, but then I thought I'll shift it to evening so everybody can attend. Okay, so tomorrow is very important class. Numericals and 5 markers. I mean derivations. 5, 3, all those markers. A beam of unpolarized light of intensity I naught is passed through a pair of Polaroids with their pass axis inclined at an angle of theta. The intensity of emergent light is equal to. Okay, Olive, happy dinner. Enjoy your dinner. See, Olive is too honest. He is eating dinner and watching my video. Yes. What is the answer? Who else is eating dinner and watching my video? Yeah, the answer is I is equal to I naught by 2 cos square theta. Which option is that? Sometimes I won't see properly. It's option D, no? I naught by 2 cos square theta. Yes, option D. Yes. Option A. It's option D. PDF I'll give. After the class, you can check the description. The team would have uploaded the PDF. Thank you, best ever information. Best ever information used to be in other classes also. I remember him. Is it a he or a she? I don't remember. Anki D. Luffy is sleeping and watching. See, I can't tell you if this would be enough to score out of out. These are some practice questions. Similar questions might come. Sometimes the same questions also might come. But similar questions will come. Okay? Yeah. See, I'm not preparing the question paper, so I'm not going to give you a 100% guarantee on only these questions will come. Yeah, all the best for your exams anyways. According to Huygens principle, the speed of the secondary wavelet is twice of the wave, zero, same of the wave, infinite. Huygens principle says that the speed is always going to be the same. All this we have discussed in the previous classes. It's going to be same. The bending of light around corners of objects, already discussed. What is the answer? It is diffraction. Yes. Yes, super. Oh my god, we are at question number 92. We're almost going to reach 100 questions. Where is your energy? All of you, quickly. At least the next questions, all of you solve in full energy. Light is a transverse electromagnetic wave. Polarization of light confirms transverse nature of light. What is this? Is option A correct? Is light a transverse wave? Yes, of course, it is a transverse wave. Polarization of light, does that confirm transverse nature of light? Yes, it does. So what is the answer? What is the answer? Answer. Yes, combat. I can't pronounce your name, Mr. Gaming. It is C. Both the statements are correct. Okay? Yes. I think the question numbers are a little, okay, they're fine. Which of the following phenomena confirms the transverse nature of light waves? Which one? Same. See, look at this. Look at this question and the previous question. They have the same meaning, but they're in two different forms. So you might get a third question in your exam which has the same meaning but in a different form. So it's important you understand the concept. See, this question says which of the following phenomena confirms transverse nature of light? The answer is obviously option C, polarization. What was the previous question? The previous question was polarization of light confirms transverse nature of light. Is it true or false? See, similar question. So you will get similar questions, but you should be able to identify that this was a similar question that we did. For that, you have to understand. Okay? Yes. To observe sustained interference pattern on a screen placed at a suitable distance in Young's double slit experiment, which of the following conditions are necessary? Source of light should be coherent, source of light should be narrow, source of light should be close. What is the answer? What is the answer? Quickly, students, what is the answer? All three. All three are important, no? Say all three. It should be coherent. It should have a constant phase. The slit should be narrow and it should be close. Very good. Emission of electrons from a metal surface by heating is called. What is it called? Photoelectric emission, thermionic emission, field emission, secondary emission. What is it called? Quickly tell me the answer. What is the answer to question number 95? Question number 95. Have you all subscribed to our channel? Please subscribe and like the channel so we can keep growing and give you wonderful content. Okay? So if you keep supporting us, you ask us for something, we will have a video on it. But for that, we need your support. Okay? So please show some love by liking, subscribing and sharing our video. Okay? Now what is the answer to this question? It is, okay, I get so many B's. Yes, it is thermionic emission. What is thermionic emission? Emission of electrons from a metal surface when it is heated. Super energy, wonderful energy. The phenomena of emission of electrons from by heating. Similar question. Thermionic emission. In photoelectric experiment, increase in the intensity of light above threshold frequency is what? What happens? Kinetic energy of photoelectrons increase in photoelectric current, decrease in kinetic energy, photoelectric current remains constant. What is the answer? What is the answer? Amulya says it's B. Okay. If Amulya says it's B, I'm also going to agree it is increase in photoelectric current. Very good. Very good. One second. Yeah. The answer is option B. Okay, students, we are at 98 questions. Quickly, I want full energy now. We have very few more questions. Quickly, please go call all your friends who left. Tell them the class is going to end. We're going to end in another 10 minutes. So quickly, full energy. Macroscopic particles in our daily life do not show wave-like properties because. Why do they not show? Because they're macroscopic. Because their wavelength is very small. If the wavelength is very small, how will they form wave-like properties? They should have some wavelength to show wave-like properties, right? Yes. Varu, my name is Catherine. Okay. Yeah. S Olive, it's blur. So if it's blur, go to settings, increase quality. Okay. And then you'll be able to see it properly. In photoelectric effect experiment, if only the frequency of incident radiation is increased, then maximum kinetic energy of photoelectron decreases, stopping potential increases, photoelectric current increases, photoelectric current decreases. What is the answer? Okay, Amulya, I'll keep telling your name then. Puneet is eating fried rice. What is the answer? Answer. What are you all discussing? You're discussing about fried rice and chicken in the chat. Tell me the answer fast, all of you. Yes, it is. Stopping potential increases. Yes, Yashwant. I also want to tell everybody the same. Concentrate in class. Thank you, Ningappa. Please let me know in the comments as well. Next question, 100th question. Can you all put some fire in the chat? We have done 100 questions. Put some fire in the chat. 100th question. You know, it's fancy, no? To see the number 100. Put some fire. Quickly. Can I have some fire in the chat? Can I have some new subscribers and some likes also since we reached the 100th question? Ma'am, how? Because we did. What is the answer to the 100th question? Quickly tell me. What is the answer? Yes, very good. The answer is electron. Super. Next question. The de Broglie wavelength of a moving particle is independent of dash of the particle. What is the answer? Is it charge, mass, speed, or momentum? Yes. Yes. Superb. It is charge. Very good. We solved 100 questions, students. 100 questions. Very good. Next question. Very easy question. Plum pudding model of an atom was given by. Who gave plum pudding model of an atom? Definitely not Einstein or Bohr or Rutherford. So it's J.J. Thomson. Otherwise also it's J.J. Thomson only. Next. At the distance of closest approach of an alpha particle with gold nucleus, what happens? What happens? Both kinetic energy and potential energy are equal. Entire kinetic energy is converted into potential. Entire potential is converted into kinetic. Both kinetic and potential are zero. What is the answer? What is the answer? Abhijit said first. Okay. 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 What is the answer? Yes, entire kinetic energy is converted into potential energy. What is happening there? The alpha particle comes, it hits, it stops. When it stops, it becomes potential, and only when it goes back, it gets converted into kinetic. Okay? Next question. The impact parameter is minimum in alpha scattering experiment for the angle. For the angle, answer. See, the impact parameter is the perpendicular distance between what? The initial velocity vector of the alpha particle and the center of the nucleus. So when alpha is directed straight towards the nucleus, it experiences maximum deflection. So how should the scattering angle be when the deflection is maximum? Yes, very good, Ritesh, 180 degree. I see other names as well. I'm not calling out all the other names. Okay. 99th answer is option C. Which was question number 99? Is it option C? Okay, find out. If it's option C, you can let me know in the comments. Now let's just move on and finish it off. Okay? Okay, Himnish. Next question. The diagram showing the standard wave pattern associated with an electron revolving in a stable orbit is shown. The principal quantum number and radius of the orbit are. What all are they? So look at the diagram. How many standing waves are there? 1, 2, 3, 4. So one wave is one crest and one trough. So the answer is definitely 4 and something. So there are 4 standing waves in the diagram. Okay. So the answer is 4 and something. So the principal quantum number n is 4 Radius of the orbit is what? R is equal to 2 lambda by pi. How do I get 2 lambda by pi? So, how will I do this? Let me do it for you. So, what do I have? I have 2 pi Rn, which is circumference. What is this equal to? N lambda. From this Rn is what? Rn is N lambda by 2 pi. Okay. Now, what is N? 4. Because there are 4 full waves. 4 lambda by 2 pi. So, this is lambda by 2 lambda by pi. So, the answer is option D. Okay. Okay, Sapphire Soul. Yes, yes. Yes, yes. Good, good. Very good, very good. Okay. When alpha particles are passed through a thin gold foil, most of them go undeviated because very easy question. I shouldn't even be discussing these questions to such smart kids. What is the answer? Yes, most of the region is empty space. See, you are all so smart. No? 107 questions, students. 107. Quickly, let's finish it off. Quickly, in another 5 minutes, we'll finish it off. What is the answer? The nuclides are they isotopes, radioactive, isotones, or isobars? What was your PU percentage, ma'am? Oh. Isobars. Very good. Tomorrow the class will be in the evening. I've not actually decided on the time exactly. But you can see it will be scheduled and then you can just look at the tomorrow by afternoon. You go check the Vedantu Karnataka. The class will be scheduled and the time will be there. Okay? It will be in the evening. And it's sometime after 5 o'clock. Okay. Nucleides with same, again, similar question. What is it? Same neutron number, different atomic number. What is it called? What is it called? Is it an isotope, isobar, radioactive nuclei, or an isotone? Very good. It's an isotone. Next, the nuclear force is. See, all these are very easy questions. Nuclear force is what? This is also homework. Very easy question. 110. Okay, how many questions do we have? Oh, we have so many questions. Okay, let's try to do 1 or 2 more questions. Which one of the following is not a characteristic of nuclear force? Nuclear force is definitely not charge dependent. So the answer is charge dependent. Okay, this is not a characteristic force. It does not depend on whether it is a proton or a neutron. Okay. Okay. For an electron revolving around the nucleus, which is the correct option? Kinetic energy and potential energy are positive. Total energy is negative. Kinetic energy is positive. Potential energy and total energy are negative. Potential energy is negative. Kinetic energy and total energy are positive. Kinetic energy and potential energy are negative. Total energy is positive. My God, I should drink some water. What is the answer? What is the answer? Quickly, quickly, quickly. D. Is it D, Amulya? C. B. Yes, Ritesh. Very good. Ritesh got it right. It is B. Very good, Ritesh. Sapphire Soul. Very good. Crystallite. Very good. Yes, Himnish. Himnish. Very good. The radioactive decay in which very high energy photons are emitted is called. Very high energy photons are emitted where? Where? In which decay? Obviously gamma decay. What is alpha decay? Alpha decay is helium nucleus. Beta decay and beta decay both are electrons. So energy is only for gamma decay. Okay? Okay, quickly last question. Nuclei with same atomic number are called. Very easy question. Isotopes. The ratio of nuclear densities of these two are. How will you do this? You should do densities mass by volume. So you will get 1:1. I want you all to try this out. Okay. Energy gap between valence band and the conduction band for a conductor is, obviously, see, similar question we have done. You can see one question can be asked in how many different forms. Okay. An intrinsic semiconductor is a substance having equal number of free electrons and at room temperature, a substance having unequal number of free electrons and holes. At room temperature, conductor at T is equal to 0 Kelvin and insulator at room temperature. What is the answer? See, intrinsic should always have equal number of free electrons and holes. Only when you dope it, it will change. Okay? Okay? Okay, we have 3 more questions. Let's quickly finish it off. P-type semiconductor is electrically. What is P-type semiconductor electrically? Obviously, neutral. Very good. Superb. Why is forward bias applied to a PN junction? When is forward bias applied to a PN junction? When is it applied? Is it to raise the potential barrier, reduce the majority, lowers potential barrier, raises the width of the depletion region? What is the answer? Yes, superb. Lowers the potential barrier. Okay, students, last and final question of this section. Last and final question of this section. The energy band gap in conductor, insulator and semiconductor are very easy question. Which should be the highest energy band gap? The smallest energy band gap should be for a conductor. After that, semiconductor, then insulator, isn't it? The band gap should be highest for insulator. So the answer is going to be E1 should be the smallest and then E2 and then, look at this, conductor, insulator, semiconductor. So conductor should be the lowest and then you should have semiconductor, then you should have insulator. So E1, E3, E2, which is option D. Okay, so with that we come to an end of more than 100 questions MCQs for your second exam or exam 2. Okay, so thank you all for being there till now and I hope you have all had a quick revision of so many MCQs. Okay, so if you have all felt this video helpful, please let me know in the comments. I will be very happy to hear that. And please share this with your friends. All the best for your exam. Don't forget, tomorrow there is another class with numericals and important questions happening in the evening after 5. Okay, the exact time you can just check the Vedantu Karnataka channel. Alright? Alright? Oh, no problem, Abhijit. Okay, so please let me know in the comments how the video was and I will see you all with another video tomorrow. Okay, bye-bye. All the best. Those who are writing biology tomorrow, all the best for you. Okay, do very well. Relax. Enjoy your exam. Okay.